Okay, so let's get started. We're going to be taking a look at setting up and working with our overrun fuel cut within our Motec M1 programming. Now, our overrun cut is going to allow us to have better fuel economy as well as improved drivability on-off throttle. We're going to talk about how that's implemented here in just a little bit. Now, the overrun cut is something that I turn on after I've calibrated my main VE table. In overrun conditions where we're in lift throttle and the engine is decelerating down into idle or just decelerating down between a gear shift, we're going to find that we pull the most inlet manifold pressure vacuum reading as the engine's running. So we'll be somewhere, depending on how much vacuum your engine pulls at idle conditions, somewhere in the last few rows in our table. If you have the overrun fuel cut turned on, it'll go naturally lean relatively quick, and we can't really get a feel for how these VE values are influencing our fueling before the overrun cut actually turns on. So we want to leave the overrun cut off, calibrate these values the best that we can, and then turn the overrun cut on after our VE table again is dialed in. Let's jump in here and take a look at how to program and set up our overrun cut. It's actually pretty basic, only a few variables we need to consider, but it is important to understand what's going on with this so we can actually implement it correctly and not create drivability problems. So I'm going to move from my fuel tuning page over to the page labeled overrun right here. In the overrun page, we find we have our setup window right here, and then we find a time plot right here. This is going to help you track if the overrun cut is actually active, seeing the influence of what's going on with the drivability. So let's jump in here to the overrun mode, and let's go from not in use, assuming the VE table is calibrated, and let's go to enable. In here, we have a bunch of variables to account for. Now, the things that we need to worry about are going to be engine speed, vehicle speed, if you have a vehicle speed sensor wired into your Motec, which you likely will, and then also throttle position. So the overrun cut is going to be triggering anytime our throttle position is less than about 0.5, 0.2% throttle, essentially zero throttle. And that's going to be tracking in a drive-by-wire situation, your accel pedal position. If you're in a cable-driven throttle body, that's going to be tracking your actual throttle position sensor fitted to your throttle body. So when we are showing approximately 0% throttle and we're exceeding the speed threshold for the engine speed and the speed threshold for the vehicle speed, it can turn on the overrun cut. When that turns on, the injector turns off, and then as we're decelling further and further into idle conditions, let's say we don't clutch in, or we don't gear shift, or we don't give it throttle, and the engine's falling slower and slower into the condition where we're going to go into idle, it will turn off the overrun cut, turn back on the injector once we reach this RPM. And then if we drop below the threshold here for vehicle speed, it'll turn back on the injector. Now, we need to do this so that we don't stall out the engine. The engine can still run with the injector off because it has momentum as it's spinning around, and we don't necessarily need to have that injector creating combustion, which saves us in fuel economy. And it can actually add up quite a bit without the overrun cut on versus it off. You can find that the economy definitely improves on any engine. So it's something to consider. Now, one thing I want to mention here is if you have a rotary engine, I don't use the overrun cut because it will shut off the fuel flow to the engine. And if you've eliminated your oil metering pump that actually injects the oil into the chamber to keep everything lubricated, and you're doing a premix in your fuel tank, that can create starvation to the rotors and to the actual internals there, so it can create problems for you and wear out things very quickly on the apex seals. So I recommend on a rotary engine to not utilize the overrun cut. Piston engine, you're fine. One detail I wanted to mention. So the other variable, or the other thing I want to mention here, is that you want to make sure that you've calibrated your throttle position sensor, whether it's going to be cable throttle position sensor or your accel pedal position sensor within a drive-by-wire format. If you don't track 0 to 100% movement in the pedal, that can cause all kinds of drivability problems with the overrun cut enabled. So definitely make sure that everything is showing and tracking correctly on and off the throttle. It's tracking 0 to 3%, back to 0 again. Everything is functioning correctly before you turn on and use the overrun cut. Now, some things to consider when we're programming our variables here. So we can find engine speed. There's a threshold and a hysteresis. We want to make sure on the threshold that this is at least 500 to 1,000 RPMs higher than any commanded idle speed.
Thanks for checking out our teaser clip. If you want to see the rest of this video and more than 500 hours of current EFI training we have to offer, make sure you click right here. If you want to go and check out more teaser clips from this training course, click here. And you don't want to miss any of the videos we're going to be releasing on this channel, so make sure you subscribe and click here. Thanks for watching, and I'll see you guys later.